right, we have hit our 5 minutes after mark, so let's go ahead and dive in. We're all busy people. We're all here to learn some things. We're all excited to learn some things, so let's go ahead. We'll halt the waiting. We'll just go ahead and dive in. So you are in the right place. If you're here to learn about AR and VR, what that means in terms of inspiring students and future careers in topics and subjects around STEM, you're in the right place. So today we're joined by Bill. We're going to be talking about hacking perception. But before we do that, let's go ahead and dive into a little bit of housekeeping. We'll go into, it's the classic agenda. We'll talk about what this group does, and a few other opportunities for all of the attendees, some of the values of the group. We'll do all that stuff first, then we'll go into the talk. So give me about 5 minutes to do so. So we're going to introduce AR and VR in the context of academia. We know, many of us who are familiar with augmented reality, virtual reality, mixed reality as well, and then the next acronym, the next, even the real reality, where we have an idea, we can use our imaginations as to how that can be applied, how 3D visualizations can be applied in the context of academia. And we'll look at a few specific use cases here, but then we're going to examine, again, how do we take that a step further? How do we look at more practical examples and move away from just the proof of concepts? And that's when we'll be diving into, again, the presentation, part 2. And then the last part, and this is a 3-part event, the last part will be breakout rooms. As we know, because of COVID, it's been challenging to meet people. And that's why we're here today, to meet other people and to have interesting conversations and continue to expand our network when unfortunately we can't meet in person. So we've been experimenting with these breakout rooms, and they've been working pretty well. We've been getting some really positive feedback. So if you like the idea of meeting some other people interested in XR and academia, definitely stick around after the talk. We'll be doing that for about the last 20% of today, 20 to 30%. So introducing the group, we are AR VR for training and education. What does that mean? Well, first of all, our mission is to build a community of knowledge sharing. So we're here, we either have our expertise in perhaps academia, or we have our expertise in a non-XR field, or we have expertise in XR. But the big question here is, how do we actually bridge the gap between the two? And that's ultimately why this group started, so that we could bring in experts from all these peripheral industries, and then we bring these experts in XR, AR, VR, that is, and then we can bridge the gap, have the right conversations, and solve the real problems that we're dealing with Monday through Friday, and even Saturday and Sunday. So how are we going to do that? Well, we have fireside chats coming up. We have webinars, we have presentations just like today. We'll be running some workshops as well. So there are many of us who are designers and developers as well. They want to get their hands dirty. They don't know how to start building VR and AR. Well, stick around. We will be running workshops very soon as well. This also doubles as a networking event. One day we'll be meeting in person. I promise, as much as I can promise. But we'll be doing virtual networking events, but we'll also do in-person networking events as well. All right, so who am I? Director of Design and co-founder of KairosXR, where we build occupational training solutions. So we specialize in augmented reality and virtual reality, and also interactive desktop 3D as well, to build training and education solutions. I'll let co-founder Andy introduce himself as well.
All right, thanks, Tim. My name is Andy. I'm on the right side of the screen there. I'm the Director of Technology at KairosXR, and I look forward to meeting everyone who is joining us today.
Sweet. So again, I mentioned it before, but what is KXR? We are a development agency in San Francisco. We work with clients globally. We build VR and AR training and education solutions. So with that said, we get excited about being a resource around development, but a resource through your learning journey as well. So we have some workshops, as we mentioned in this in the intro there. We have some workshops, and we offer custom development services as well. So if you're interested in learning about mobile augmented reality, or you're interested in getting your feet wet with some of the hardware in the industry, or you'd like to learn more about virtual reality instead of augmented reality, then definitely shoot us a note. We'll have our contact information at the end of this, but we'd love to talk to you around best practices to learn more in those fields, or some of the details of the workshops we offer as well. So with all that being said, we're here to talk about XR in academia. So let's go ahead and do that. And bandwidth doesn't always permit these videos to load, and maybe they might be coming in choppy on your end, so do excuse the choppiness. But here are a few slides with proof of concepts and fully fledged products that teams in classrooms are rolling out today. So on the left here, we have, I believe it's Ajna Lens, and they're building an education, a high fidelity education platform combining both mixed reality, hologram technology, but for the most part, augmented reality as well for the classroom. And on the right, we have a VR use case. So there are fundamental differences here. And again, for those of us who are familiar with augmented versus virtual reality, you already understand the concept. You understand the fundamental differences between the two. But for those who are less familiar with AR versus VR, mixed reality versus VR, again, on the left, as you can see virtual objects displayed in the world around the users, and they still see the context of their real world environment. Versus looking to the right video, where we have virtual reality, where there's an entirely digital world around the users, and you can see there are other users in there as well. This is an example of a virtual reality field trip. Now it's an example of looking at certain equipment, VR as well. So really, the reach and the scalability of this technology for academia is pretty much limitless, or at least it's limited by access to the hardware. And we'll get into a few workarounds in Bill's talk as well. So those are a few fundamental examples, but a less obvious example is Half-Life Alyx, which is on the left. This is a AAA game that was recently released. And what's really exciting about this is it's a game first, the AAA game first, virtual reality, but we have a math teacher here actually teaching math in the game. So all of a sudden you see this continued theme around using gaming technology for classroom use cases. And we see it in Discord as well. We can see it totally spacing on a game now. There's just that massive concert in there. Totally lost it. Either way, you're using these massive open worlds for other purposes, not just, say, a shooting game or in a big adventure game. You're using it for educational use cases. And obviously you have access from there, or maybe less obviously, but you do have access to a very different crop of students, which is really what this is about. How do you reach as many students as possible, and how do you inspire as many students as possible?
Yeah, it was Fortnite was the game, Tim.
Fortnite, yeah, thank you. One of the largest games ever. Yeah, Fortnite. So using the Fortnite platform, for instance, either as a concert venue and perhaps as an educational tool, a workshop tool, if you will. On the right, in terms of the actual technical architecture to build this, we have a simpler tool than Half-Life on the left, and it's AR. We're just using image recognition on the right as 3D visualization. It is interactive, and as you can see, we have certain educational games as well. These are for kids. But BitAR was the development team that built this out. So they have a platform using image recognition to sponsor an educational experiences. And last few examples before we dive into the presentation here. Again, more closely related to STEM. On the right, we have the healthcare example, but using another example of image recognition for augmented reality, mobile augmented reality. In this case, it's an older iPad, but certainly possible with your phone as well. And then on the left, we have a more specific example with STEM. So teaching mathematical and engineering concepts, not just 3D visualization for the sake of exposure, but really interacting with these concepts as well, solving problems, critically thinking about it, and using different applications. This video actually features different applications to explore these concepts. And not just augmented reality, not just VR, but interactive 3D desktop as well. The team using this was Purdue University, their I believe it's their mechanical engineering program. So at any rate, let me know in the chat if you guys have any other questions. We will dive further into this later on in the presentation, but this is a warm-up. This is just to get your, again, your feet a little wet before we dive into the presentation. Then we'll continue the conversation on the other side in our breakout rooms. So I'm going to pass it over to Andy for the introduction, and I'll let you take it from here.
Awesome. Thank you, Tim. And before I dive in here, I want to reiterate that if you have questions, please drop those in the chat. I see a couple questions that have already come in. We will answer those, and we can take those into the breakout rooms in the second half as well. So today I'm really excited to announce very presenter. He designs novel interactive experiences for major museums. He's worked with Oculus founders, UC Berkeley, AdoptAPet.com, and Qualcomm, to name a few. He directed new media and developed interactive experiences at San Francisco's Exploratorium, which is San Francisco's science museum. He worked there for over a decade. He's worked with the Virtual Science Center as the Chief Experience Officer, and he's taught UX and exhibit design at NYU and General Assembly. Bill Meyer is the Principal and Interactive Immersive Experience Designer at Inquireables. And before I pass it over to Bill, I will again make a mention that if you have questions on what Bill is presenting, please drop those in the chat. We will have a few minutes after his presentation to have a little Q&A. But with that said, I will turn it over to you, Bill.
Great. Well, I'm thrilled to be here, Andy and Tim. So let me share my screen. I'll talk about this at the very end. And there we go. So I'm going to start by just jumping in and showing you guys a short video, and then I'll talk a little bit about it after. So you're going to see what she's seeing in virtual reality and hearing. And then as she turns back to the front screen, she's prompted to slide the headset up onto her forehead, and you get this curious effect. And what's up with that? So I will talk about that definitely as we get a little further into this. So hopefully that made you a little bit curious, and hold on to that. What I'm going to start with and is show you a number of exhibits that are from a traveling exhibition called Reinventing Reality, which is currently at Lawrence Hall of Science, which is part of UC Berkeley in the Bay Area. And this is an exhibition that is designed to travel for 5 years. So although, like everything else, it's stalled at the moment, it'll be traveling through North America. And at the very end, I'll have a link to the Virtual Science Center. They will be happy to talk to you about bringing it to a city near you, and you'll get a pretty good sense, I think, of what that exhibition is by the time we're done. So what I excel at is sort of creating experiences that make complex topics simple, fun, and relatable. So I'm just going to jump right in, and I'll show you some examples of this. That first strange phenomenon you saw, which is called motion parallax, hopefully stimulated some curiosity, and that's at the heart of what's called inquiry-based learning. And this is, if you've been to the Exploratorium, pretty much all of those exhibits are using this concept, meaning that you want to get somebody curious about something so that they actually want to know more about how the heck does this thing work? And then the learning doesn't feel like learning. So what I showed you a moment ago was a prototype, and this is the finished exhibit as it exists right now in the traveling exhibition. This is at Lawrence Hall. So the content is different, but the visitor explores VR, and then they get this curious effect when they're prompted to move the headset up under their forehead, and they move their head from side to side, and then the VR continues outside the headset. So that prompts people to sort of understand that, whoa, this is going to be interesting. That they're actually going to break this apart. And the goal of this in general is to get kids interested in STEM. So you want to, we have information about how these things work, but you want people to understand that they can figure this out on their own. I'll show you a couple of exhibits that are based on this concept. So there was a drawing exercise that was first described in this 1939 book. And it's a very fun one if you've never tried this before. You have a fixed perspective that doesn't move. You have a clear plane that also doesn't move. And then if you simply trace what it is you see onto that plane, I don't care if you've never drawn before, you are going to do a pretty perfect perspective picture. And people regularly surprise themselves with this. So this is how we leverage that to help explain what was going on, what goes on in a virtual reality headset. So this is a digital side of this exhibit, and then this is an exact duplicate analog side. So there's 3 drawing stations that are at very specific positions. Nothing special about the positions other than they don't change. And visitors can trace, they can do that exercise that you saw. And then there's a companion side, which is, again, exactly the same size digital models. And most importantly, the perspective drawing stations are in exactly the same positions relative to that virtual world. And visitors find out, like, whoa, those drawings that I just did over on the other side line up exactly. And they also find out that even when things aren't moving, that what's really happening is you're looking at an animation that's being refreshed 90 times a second for your perspective. And that is what is actually happening inside a virtual reality headset. Only normally, if it's working really well, you wouldn't notice it because it just looks so real. And this, by taking it outside the headset, again, for the educational content, lets people have the kind of a conversation that we are having right now. People can share this experience. So here's what that finished exhibit looks like. So you can see, I'm showing you the one side here, which is the physical models. And then this is the exact duplicate digital model. And here now we have the headset on a rail, and you just slide it between those 3 positions, and you can compare those to what you did on the other side, and they line up exactly. So this is at the heart of what is going on in VR. Whoops, let me do that. So what I'm going to talk about for a second now is the process that that these exhibits got developed. So in the very beginning, I dove deeply into the content, talked to subject matter experts. We did focus groups and interviews. And then I should mention I was working with an amazing team. On the East Coast, the Quattrophone Associates did the lion's share of the programming and the visual design, and just a tremendous amount of work on the development of these exhibits. And then the Virtual Science Center, of course. And so we all came together and then tested things at the Tech Museum in San Jose and at the Maryland Science Center in Maryland. And then ultimately you take these things and you put them out there and you stand back, and then you make more observations about, okay, well, how are people just using these things? So that was the process through which we iterated these designs to be able to get to what you're seeing now. So that first 3D effect that you saw really only requires one eye to work. So you could be blind in one eye, you could have one eye closed, and people could still drive cars. And people often don't realize that the 2-eye stereoscopic vision, which is called stereopsis, that people so commonly think of as where depth perception comes from, is only one but very important depth cue. And that has a lot to do with when you're doing close work. If you're threading a needle and you don't have 2 eyes, it'll be a lot harder. But how does that work? So in the 1850s, Charles Wheatstone created this model to kind of explore this. And I use this as the basis for the next exhibit I'll show you. So it involves a couple of mirrors, and there's displays on either side. And what we did, and almost all of the exhibits here were programmed in Unity. We took the left feed, what would go to your left eye, put that out to a monitor on the left side. We took the right eye feed to a monitor on the right side, and then when the visitor leans in, they get this fused stereoscopic effect. So this is what that looks like. Now, Tim and Andy might recognize this, because this was sitting in an office that we all shared back in a former life. So for the 3D effect to happen, no movement on the visitor's part or in the model is required, although we let visitors animate this because, hey, that's more fun too. But you find out that, wow, even when that's a still image, it looks three-dimensional. And here's that finished version where the content is different. Now there's a theme going on here with space, you know, to make it more inviting. And you can see some of the what's going on information around it. So when somebody's curiosity has been stimulated, they can jump in and take the next step and actually get an answer to their question about how does this work. But the best kind of learning happens when that's the order in which things proceed, when the curiosity is stimulated and then the answers are, you know, the learner is hungry for those answers. So the exhibits in this exhibition were designed to coincide with what teachers are teaching, and particularly in the middle schools. Now, these exhibits, you know, I really, you know, encourage the team at every stage of our development to make sure that these things would be equally interesting for, you know, a 70-year-old as for, you know, a 17-year-old or a 7-year-old. But there was a big focus on, hey, you want field trips to be able to come in and teachers to be able to go back in the classroom and take things to the next level. So in 8th grade geometry, the kids are already learning about what are called rotations and translations. And I don't know how much background people have on virtual reality, but when you're talking about, if you're familiar with a Google Cardboard, where you just drop your mobile phone into a little cardboard box that has a couple of lenses on it, that tracks the rotation of your head. Are you looking up? Are you looking down to the side? And that's good enough for 360 videos. When you add in translation and you have, that's moving my head forward, back, side to side. So if a VR system can track that and it also knows what direction I'm looking, you put that together, you get what's called 6 degrees of freedom. That's what's going on in an Oculus Quest, in a you know, in a Vive, in you know, any of the higher end headsets. And that's where you're really, you know, in full VR. So the exhibit that we did that lets visitors play with this very, you know, possibly dry concept is to take that tracking of which direction am I looking, and, you know, am I moving forward or back, and turn that on and off selectively. So here's how that works. This is at the Marion Science Center testing. So it's just translation happening now. So that's why when he rotates it, the model doesn't change. He has both turned on right now. So I don't know if you heard that, but she said she was definitely tripping. So that's where things, you know, get really interesting. This is what that finished exhibit looks like. And then there's a couple of other exhibits. This specifically gets into the type of tracking that's in like an Oculus Quest, which is called Inside Out, where there are cameras that are looking at the outside world. It's very related to how augmented reality apps track, you know, the position of the screen. So the first couple of things I showed you had to do with, you know, with visual and tracking, but, you know, a very important aspect of virtual reality and mixed reality is spatialized audio. So that's where you hear sound. If you hear a bird tweeting, you know, and there's a bird in the scene, the tweet is matching where the bird is at. So I wanted to physicalize this. So this is an early concept drawing I did of the original idea, which was to recreate the physical kiosk area that a visitor is standing at in virtual reality. Just like you saw in that first one, keep the head tracked, and you can slide the headset up to the forehead. Each object that a visitor can move around has an RFID tag on it. And then the reader can tell the position. So if you place an object down, it knows when that object is there. And then you get the sense that that sound is actually coming from, from that object. So here's again an earlier prototype of this exhibit that was done at the that we tried out at the Maryland Science Center. So it's kind of set up as a game, and here what you're trying to do is figure out where you hear a musician playing and you hear a guitar, like where is that guitar player at, and then you place the object there, and you do that for the whole band. And the idea for this. For the musicians came from Quatrefoil, which I thought was really, it made this thing so much more engaging. So there, she placed that, and she, here's the music, I think that got the band playing. Here is the final exhibition version of this, but if you look at the screen, you'll notice that her head is being tracked, and we, instead of using a headset, we actually adapted a hand controller up there, but it doesn't look quite like that, fortunately. So you can see that her head is being tracked on the display of what's in VR, because there's a VR simulation behind the scenes here. And she was able to hear where that was. She's got 3 of them placed, and now she's going to place the final one. So she's listening for where that sound appears to be coming from. And boom, now you get the whole band. And there you have that. So there's 2 more I'll show you. So there's one, I'm not going into the visual illusions. There's a section of the exhibition which has some very curious visual and audio illusions. But the big idea here is that our experience of reality really is something that's constructed. So this was a kind of a abstract idea for people for virtual reality. Now, people sort of realize, oh, that actually is true, because you just give a few cues and all of a sudden, boom, you feel like you're in this place that doesn't physically exist. So the visual perceptual illusions, kind of start to show the chinks in the armor that we don't normally realize that we're in fact constructing our reality. So there's a body illusion. This was done out of Mel Slater's lab that I sort of help the team convert this into an exhibit experience. So this, I'll show you how that works. So we've got again, a complete recreation in virtual reality of what exists in the physical space. There's a brush, a real brush that brushes the visitor's hand. And then in VR, while you're feeling that sensation of your hand being brushed, you see your hand being extended. And that fools your brain, and your brain goes along for the ride and just decides like, whoa, my arm just got longer. So this is the testing at the Maryland Science Center. And what we did here was we attached the brush to a hand controller so that we could exactly track that position in VR. So you see your hand is getting brushed and the arm is now extending in VR. And here's what the experience is.
It's pretty cool. It feels like your feels like your arm is all the way out there as he's brushing it.
So that was, you want to get this kind of feedback because you don't want to move forward with what is a fairly complicated exhibit if it's not a strong experience for people. Here is that exhibit in the final traveling show. So now it's all been automated. So she's getting brushed in real life. It's also happening in what she's seeing in virtual reality. She sees her arm stretching. And she's feeling that her arm has stretched.
How does it?
this has to do with the mind?
So people really, this really tweaks your sense of self-perception, because you wouldn't normally think you could imagine that your body is different than what it in fact is, or that your body could feel different than what it in fact is. Now, the last exhibit I'll show, I want to comment also that this exhibition is in English and Spanish, so you may have seen some Spanish on there. So all of the exhibits are bilingual, and it'll likely be traveling to Canada, and that version of it will have French. So this exhibit had to do with helping people understand how reality capture and depth cameras in particular work. So depth cameras, well, reality capture, things like that, that's what's going on the top of driverless cars. And Intel, which is what we're using here, came out with a camera called the RealSense. And it has actually 2 different cameras on it, and it's always comparing those 2 views. So it captures all these points in this, what the surface of your body is topographically. So this is testing at the Tech Museum. So we found here that people weren't really quite getting that that was really capturing a 3D, image of the surface of their body. We included this pin screen to help people get that concept, and it really is a good analogy, but still we needed to go a little bit further. So I'll show you what the final exhibit of this is, but what I decided to do was, and this was a bit of a stretch for the team, but people came through great on this, and we created a VR app, and had some help from Solaris Knight, if anybody knows him, also for this. So what this does is it takes that point cloud data and lets somebody move it around and walk around that point cloud. So here you see the person on the left getting captured, and then you can just move that iPad, and with augmented reality, you can go to the side, to the front, and you can see that camera is only capturing the front surface, because that's all, we only have 1 camera, and that's all it's seeing. Now this relates to actually to trigonometry. So teachers back in the classroom, like they could do with the translation rotation, they can, you can make a little problem, and I put that actually in a guide that goes along with this. That you can figure out how is it using trigonometry to just use the Pythagorean theorem and go, okay, if I have, if it looks this way from this angle and this way from this other camera that I know is this far apart, you can compute the distance, and that's what it's doing for all the different points that the camera is mapping. I'm going to show you one of, so there's an article which I believe is linked to on the Meetup page. So this, a lot of what we were doing in this exhibition is called passive haptics. So when you see something in the real world and you can touch it in the real world, but it's also being recreated in VR, that's known as what's called passive haptics. So this paper dives into some of these concepts. I wrote this to sort of help the museum community stretch their thinking about where museums could be going. And this introduces a concept of location, what I call location-based exhibits. So, you could take experiences from museums all over the world, but then have them play locally. And of course, right now, not everybody has a headset at home. So this is a way of bringing museum experiences, of this amazing content that's all over the world, right to where people are at. Now, it could come into your home, obviously on a VR headset, but it also could come to a little location where there's a space that's of a set size that uses the affordances, the advantages of having a little tactile space that you can touch of a known size, but then you're also adding VR onto it. It makes the experience of presence much deeper. And this goes into one thing I was talking with Andy and Tim about, specifically for people who may or may not be familiar with something called SCORM and the Experience API. This is really trying to paint a picture of how this could all come together. but talk specifically about how educators and the military has used this for years, and the Department of Defense really is what drove the development of this learning platform to track informal learning. And it's an open source thing that anybody can build upon. So that's in the references here. So that'll be linked to on the Meetup page. So let me go back to this, and then so this is my contact info and LinkedIn profile. You can see much of what I've shown you at Inquireables.com. The virtualsciencecenter.org site obviously is like the place to go if this exhibition in particular interests you, and you want to try to help bring the exhibition or parts of that exhibition, to your city, then they're the people to talk to. And then this is a shortcut link, so it's bit.ly/as-we-may-learn, which will take you to that paper that I just showed you. And with that, I'll open it up to any questions you guys have.
All right, thanks, Bill. That was fantastic. And as we move into this Q&A session, we just have a couple of minutes here. We do want to reserve some time for the breakout rooms. So I saw a couple questions come in through the chat. We actually had a couple questions submitted beforehand. And just a reminder that you can submit questions beforehand using the form in the Meetup. So I'm going to hit a couple of these questions that came beforehand. We had a couple already in the chat. Feel free to drop additional questions as we're going through this. But Bill, we had a question about where you draw inspiration for these exhibits. How do you qualify an idea, and how do you know what are some of the telltale signs that it's going to be make for a good exhibit?
What I do is I, first of all, look for things that are interesting to me, or that I see are very interesting to other people. So what I did specifically for this exhibition was I spent, I would say, side by side with other things, a good part of a year, really diving deep into how VR works and creating this very, very detailed content outline that was for me and the team, so that we could start to look through this and find out, okay, where are the things that are interesting? But specifically, I went through this vast content outline, and then that I created, and then went through and said, okay, but which of these things are actual experiences? So if something wasn't something that somebody could touch, see, feel in the present, that was already something that I would sort of set to the side. So I was trying to, so that narrowed the field. But I would say that's it, and then trying to figure out, like, what's the simplest way to test an idea. So in fact, you helped Andy with one of these things, like, and that was an example of where something we didn't end up actually going with one of those things. You helped with a few things, but where we tried it, we said, oh, it's not a strong enough effect. But you're really looking for things that have actual experiences, and then you try them really quickly. And then the one other thing I'll say is, when you do these kinds of testing, there's really two things that happen in my experience. If you have what you think is a great idea, visitors either don't do what you wanted them to do, or they do something different. And you have to be open to sometimes that something different that they're doing is actually where the exhibit is. So, I could give you examples from a bunch of things I did at the Sportorium, but very often, you have to really come up with a basic idea, get people to try it, and then sort of let the visitor, the user sort of tell you what this then needs to be. So
right. And so when you're discovering things that are interesting, do you find that having experience in a certain topic, so obviously you're very experienced with immersive technology, do you find that your lens with that experience allows you to find more interesting exhibits, or do you think that being relatively new and fresh gives you a specific lens that maybe allows you to find things that are more interesting?
I would say the latter. So for instance, like when I came onto this project, I mean, I directed new media at the Sportorium, and but I was no expert in virtual reality. I mean, I really, I would not have been able to tell you what 3 degrees of freedom or 6 degrees of freedom was. I mean, so I think that should be encouraging to anybody who wants to develop these types of things. I think that you're jaded if you know a topic too well. Well, it's two things. You're jaded, or you might jump to things that are too complicated because you're not seeing the fundamental questions, the 3 fundamental questions that are underneath this thing that you think is really neat. So no, so I would say that even if you know about the topic, you want to kind of get, if people, there was a book called Zen Mind, Beginner's Mind, which is what I'm sort of quoting from, but I would definitely go for the beginner's mind. Always try to be, hey, let's pretend I didn't know anything about this. What would really be interesting and accessible to me? And then start with that.
Right. That makes sense. Let's see here. I saw one come in the chat. Bill, is there a specific learning model that you use as the basis for these exhibits? Give it any sort of framework.
Well, I would say it's inquiry-based learning, and that goes back to, John Dewey, and sort of, for people who sort of are more in learning technologies or learning in those theories. I'm not an expert in all of these things, but I would say the other thing that I use comes from like Vygotsky, which would be like scaffolding. So that happens in the exhibition, although it was really important that these things be free choice, that you could pretty much go to things in any order. There is a scaffolding that happens, and what scaffolding is where you learn this one concept, and then the next thing you can build on the next thing because it's required this little earlier knowledge. So scaffolding happens in this exhibition even if it happens out of order, because for instance, you could learn about how the binocular perception works if you happen to go to that exhibit first. And then you learn about the motion parallax and this one-eyed monocular depth perception. But in either case, you start to figure out that, oh, wow, I don't just perceive depth in one way. And then there's also like a very large trompe l'oeil, which is at the entrance of the exhibit, which has these visual, all these visual cues of, that make you, you've seen these things maybe done in chalk on the sidewalk where it looks like a crevice, that's going into the center of the earth or something. So all these things, you realize like that's how depth perception. So that would all be examples of, I would say, a scaffolding method.
Right on. Well, Bill, we really appreciate you taking the time to present today. It's really fascinating, as always. Really appreciate your work. For anyone who's interested, as we've seen here, and I've worked with Bill in the past, so has Tim, Bill is a rare combination of experienced designer and technologist. So if you have any work that you'd like to work with Bill on, he does consult in the experience design space. So feel free to reach out. And again, thank you, Bill, for joining and running us through that presentation. It was awesome. And with that, I'm going to turn it back over to Tim, and we will spend the last few minutes here doing a little bit of speed networking.
Sweet. All right. So I hope that everybody can see my screen. So before we hop into the networking, I mean, some people really enjoy, other people like to drop off. Before everybody drops off, we do want to mention some of the other opportunities for you, some of the other events that are coming up as well. So if you like this one, and in particular, maybe you like architecture as well, or you are curious about XR and safety training and construction, or perhaps you're interested in automotive design and manufacturing, how XR is used both from an education and training standpoint, but then also from an acceleration of the design standpoint. Again, in the automotive industry, we have those events coming up. So in the next few weeks, the next one will revolve around architecture from the education and training context, then construction, then automotive design. If you have any questions or any kind of feedback, or you just want to keep in touch, feel free to drop your email in this contact list. A lot of the conversations that come out in this next period should be continued, and the participants very much want to continue it. So if you would like to reach out to anybody here, or if you'd like anybody to reach out to you, for instance, if you have a certain service you'd like to promote or anything like that, feel free to add your contact to the contact list. And Andy, if you wouldn't mind, I actually don't see the chat, so maybe you've already done it, but if you could add that bit.ly link, the contact list, XR4TE, to the chat, that'd be dandy. And again, feedback, let us know in this bottom bit.ly link, XR4TE_post events. And lastly, if you have any questions for Andy or myself, and again, we're about to hop into breakout rooms, so we're not going anywhere, but if you have any questions for us, connect with us on LinkedIn. We're always happy to continue the conversation. Again, our goal is to be a continued resource for you. So with that said, in the spirit of being a continued resource, there's our email at the bottom and the bit.ly links as well to our respective LinkedIns. So let's go ahead and do just that, guys. So we're going to go ahead and try the virtual breakout rooms. Now here's a little intro. Here's a little, not necessarily a warning, but there are those of us where virtual breakout rooms come more naturally. Some of us are more comfortable with them. You may find that you're going to hop into a virtual breakout room and the other person may not say anything, or you guys are going to be best friends right away, and everything in between. So that's typically how these things go. And we like to provide a little bit of a prompt for you, just as a little icebreaker. So the next slide will actually be a prompt just to get the creative juices going, the conversations. We'll meet for 5 to 10 minutes, and then we'll come back together, do a little group discussion, and then we'll actually do it again. And then from there, everybody can drop off whenever they're ready. But we typically try to do these breakout rooms to maximize the network advantage and network growth a few times. So this first one is always the background and the introduction. So just as a general icebreaker, what do you do and why are you interested in this meetup? What brought you here today? And then the second one will revolve around what's your favorite class of all time and how could immersive technology be used to enhance that course? And then would AR versus VR be more effective? So let's go ahead and dive into those. Andy, I believe that you have the keys to that car. So if you wouldn't mind, please break us into rooms of 3 to 4. And then we'll come back together in a few minutes.